Good morning, everyone. So today we're going to be taking that idea of distance equals rate times time, a formula that we learned about in chapter 2, and we're going to be doing some more with it now that we've learned some more skills. So back in chapter 2, we might look at a question like this. Find the distance a car travels when the average speed is 50 miles per hour, and they drive for 3 hours and 20 minutes. Okay, so remember D equals R times T. All right, so we want to think about what we have and what we don't have, what we're looking for. Well, it says find the distance. So that's the question. So I'm trying to find D. That is what I call the unknown, right? So I'm going to put a question mark. My rate, remember we think of rate as a speed or a velocity, and that is 50 miles per hour. So it's 50, our rate. Now, they drive for 3 hours and 20 minutes. That's our time. But remember, because it's in hours, we've got to put 20 minutes into hours. So 20 minutes is 20 of 60 minutes, because there's 60 minutes in 1 hour, which is 1/3. So we actually have 3 1/3 hours. So I'm going to plug them in, but remember when we're talking about multiplying fractions, we can't multiply a mixed number, so we have to turn it into an improper fraction, which would be 3 times 3 plus 1, so 10/3. Okay, so my distance. My distance would be my rate of 50 times 10 over 3. Okay, so now I'm going to multiply. Now remember, you can help yourself by putting that 50 over 1. And if we could simplify, we would, but we can't. So we're going to get 50 times 10. And I'm going to use that trick. I'm going to do 50 times 1 and add a 0. So 500 over 3. Now I can grab that calculator just to see what the actual distance is. It's okay that it's a decimal. We still can use it. Decimals still relate to numbers for me. So I'm going to do 500 divided by 3, and I get 166.6 repeating, which I know is 6, which is 2/3. So 166 and 2/3 miles. That's how far I've gone. All right. How are we going to use this? Well, we're going to use this by looking at something called D equals R times T problems. But our problems are going to involve something called uniform motion. Uniform motion is when an object moves without changing its speed or rate. So we don't have to worry about if the car sped up or if the boat sped up. We're gonna be dealing with uniform motion, so going the same rate. Okay. All right. So here's an example. There are 3 examples. Our first example deals with when they're going in opposite directions. So Coach Fred, she likes a process. So these are going to be opposite directions. So we've got bicyclists Brent and Jane. They started at noon from point 60 kilometers apart, and they rode towards each other, meeting at 1:30. Brent's speed was 4 kilometers greater than Jane's speed. Find their speeds. All right, well, what's a picture of this? Okay, so they're 60 miles apart. So I actually draw a segment that is of length 60, because that's basically how far apart they are. And so here's Brent. I'm going to put a B here. And here's Jane. And so they're going towards each other, which means they're going in opposite directions. Okay? Now, the thing about it is that picture is going to help us. So I just like to see what I have going on. So I know that Brent and Jane's is going to add up to 60. Okay? All right, so I've got let statements. The question actually said find their speed. So that is what is unknown. So I'm going to let R equal Jane's speed. Now, why Jane's speed? Remember, I always told you earlier that one technique is to go with the person who is going slower or smaller values. And we know that Jane is going slower. And that Brent is going 4 kilometers greater. So that would be R plus 4 is going to be Brent's speed. So I've got Jane's speed and I've got Brent's speed. Okay, now we're going to gather all our information in our chart. Now, we've done this before, so we know our formula is D equals R times T. All right, now we've got to fill in what we have. So we know that Jane's speed, and I'm going to put Jane here and Brent here. I'm going to label my chart. Jane's speed was R, and Brent's speed was R plus 4. We also know that they left at noon, 60 kilometers apart, and they traveled They met each other at 1:30. That means that here they reached each other, wherever that is. They reached each other at 1:30. So they've been on the road for an hour and a half. All right, so I'm going to do that by, in my chart, my time, I'm going to put 1.5 because that's an hour and a half, okay? All right, and it's okay to use decimals. Now here's the different part. We need to multiply them together to get the distance. We don't know what the distance is, so r times t is actually my distance in terms of r, okay? So 1.5 times r is 1.5 r, and then Brent's distance would be 1.5 times r plus 4. Noticing I'm putting the r plus 4 in parentheses. That's important, okay? All right, so now we write our equation and solve. So remember that picture was Brent's distance and Jane's distance had to add to 60. So the sum of these two parts have to equal 60. And so we know that this is Brent's distance and this is Jane's distance. So my equation is going to be 1.5 r plus 1.5 times r plus 4 has to equal 60. And now I got to just do the math. You know that we would distribute here 1.5 to each, and we get 1.5 r plus 1.5 r plus 6 equals 60. Now, I love this one because when I combine 1.5 r and 1.5 r, those like terms, sorry, let me use the same variable, that gives me 3r plus 6 equals 60. And it's an equation that is quite simple. I know how to solve that. I'm going to subtract 6 to both sides, getting 3r equals 54, and then I'm going to divide by 3. That gives me r equals 18. Now, the question asked me to find their speeds. So Jane's speed is 18 kilometers an hour, and Brent's would be 4 more than that, so 22 kilometers an hour. All right, guys, so I'm going to stop this first video here. I want you to take a quick break and then come back and watch video number 2. Have a great day.